Okay, so we are in the recording mode, yeah. This one done, teaching plan. Okay. This is so can you see my screen or not?
Yes, yes.
Okay, thank you. So this is the fundamental of a single phase, single phase is a AC, AC signal. We call as a signal. I'm sorry, I forgot to take my the pad, so I need to use mouse to write out. So what is a single phase or AC signal? The usual things, the easiest one. And if let's say you've gone through the internship, maybe you will still remember about the sinusoidal voltage. So usually we when we tap our measuring instruments in the DNB outlet, so we will measure it. It is actually a sine wave. So, okay. So sine wave, some of the indicator we call annotation. 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 Or variables. Or variables. Hello? Any problem? Tadi itu siapa? Right. So we have annotation and variables. Annotation is like we give the name of the things the parameter. For example, this is T. If let's say we do not give a name, we don't know what is the suitable name for them, abbreviation. So here we put T1 is actually period number 1. Period number 1. We go through first This was macam kacang this one. T2 is period number 2. So how to measure the period is actually when it starts from here, then it will start again from here. So for example, 1 cycle, then it repeat again, second cycle. This is called period. Or we took from this point. So 1 cycle, then another cycle. Okay, here we repeated. So that's called period. And then E1 and T1 is instantaneous. Instant. You know, instant noodles, Maggi mee. Instantaneous maksudnya pada masa itu. Okay, for example, this is 0 volt, 3 volt, 4 volt, 5 volt, 4 volt, 3 volt, 0, negative 2.5, negative 5. Okay, so at the time T1, which is equals to 1 second, for example, so my voltage is about 4 volt. At that instant, it is 4 volt. We call instantaneous. For example, let's say I want to take the reading here. So what is the instantaneous voltage? It is maybe negative 4.5 volt. So at that instance, the voltage is for that. And then what is EM? EM is the peak value, peak value of the EMF. EMF. And then, or we call maximum. Okay. And then we have a time. We have a E peak to peak voltage from this peak to this peak. Okay. So first of all, I hope that I would like to bring this info for you guys, especially when you want to deal with your final year project. The first thing, I found a lot of students, when we ask what is this info, they directly just sama dengan saya, just talk about this. No, it is not. Just now I did a wrong thing. I need to tell you that this is the voltage versus time. Then we need to let the audience know, oh, okay, now we are talking about voltage versus time. So what is the axis? Axis is a E, and the axis X is a T, something like this. So as overall, it becomes a sinusoidal voltage. Okay or not? Do you have any question?
No, sir, no.
Thank you very much. Thank you. So let's have some example. What is the peak value of this voltage? So we have a 8 volt 8 volt. What is the instantaneous value at the 0.3 and 0.6? So 0.3 is here. So at that instant, it is negative 8 volt. Okay, at 0.6, it is 0 volt. And then what is the peak to peak value? From this peak to this peak value. So this is 8, negative 8. So 8 minus negative 8, it becomes 16. Okay. What is the period of the waveform? Period. So one period like this, second period like this, third period like this. So this is the time where it is a 0.4 second. How many cycles are here? 1, 2, 3 and half. So 3.5. Then what is the frequency? Frequency is actually 1 over t. 1 over 0.4. We have 2.5 hertz. Which means the frequency means we have a 2.5 cycle within 1 second. So now this is 1 second, right? So let's have a count. Is it 2.5 cycle? 1 cycle, 2 cycle, 3, okay, 2.5. This is half. Okay, and up to here, okay or not?
Okay.
Okay, next. So, okay, do I need to share with you about how to do the conversion from radian to degree or degree to radian or not? Yes or no? No, I will skip. No, which means, do I need to explain or not? If I say I don't need to explain, I will skip it.
Maybe not good.
Maybe not, So I will skip it, Make sure you know, because in this subject, we'll do a lot of conversion. Okay, Okay, so general format for the sinusoidal voltage or current. Now you know engineer. Okay, before that, I want to ask you guys. I think you guys already did your internship in the company, right? Can I know what is the purpose of doing as an engineer? It's okay. Can share with me, no problem. What is the purpose you want to? What is the purpose of engineer in the industry, lah? What is the purpose? Moshi moshi. Moshi moshi.
Design maybe.
Okay, design then. Any others? Any others? Come. Give me some idea. You know, when the class no idea, the class is quite difficult to go on. Design idea. Then any other else? Earn money, right or not? Earn money. To get some income.
Solve problem.
Solve problem. Okay. Okay, solve problem. Anything else? No more, Okay. You know, yeah, actually, basically, you are correct, design something, you want to solve the problem, and then want to earn the money, and then, okay, when you want to design or you want to solve the problem, during the process, do you found that, or you need to do some complex things? Do you? Do you found that we need to use some complex things to do to solve the problem?
Yes.
Right or not? So actually, I found that engineer is something like is a human who make the simple thing become complex. Do you understand or not? Engineer, okay, they want to solve the problem, but in order to solve it, become very professional. What they need to do is they need to make the outcome on the paper writing. It seems very complex. Do you found this characteristic or not? Ada? Ada tak? Ada tak ada? Halo. Ada, tak ada? Tak ada? Okay, so my opinion only lah. That is my opinion. Engineer or scientist, they want to solve a problem, and then when they want to solve a problem, and at the same time they want to show that they are very professional. What they do is they pick up the simple thing, but they put it in a very complex thing. For example, we want to make this signal into a mathematics. So I can do like this. I also can do like this. I also can do like this. I also can do like this, and I also can do like this. So which one is simple? Top one, right? Which one is complex? Bottom one, right?
Yeah.
Right not? So engineer and scientist buat apa? They do something simple, become very difficult. This is my opinion lah. But no choice, because it looks very professional. When we see this one, oh lama, what is that? Something looks very difficult, you know. In fact, we only need to show this one, very simple. Okay, so general format for the sinusoidal voltage or current actually it comes from here. AM sine alpha. AM is the peak, right? AM is a peak, and then alpha is actually this one. Then this is a V lah, for example, V equals to AM sine alpha. But alpha inside got so many things, right? What they need to do is they change into rotational. Alpha is in electrical, but that it need to relate to mechanical rotational. You see, that's another different things. Not mechanical sorry, I would say that periodic. It is periodic because one cycle, two cycle like this. Okay, so and then sometimes it will not start from here, it will start from this side. So what you need to do is plus minus theta. So which means when it start from here it might plus, when it start from here it might be negative. So it depends what type of a circle, what type of the signal. So the easiest thing is we just memorize this one. AM sine omega t plus minus theta. This is the general one. We call phase relationship. So for example, one is I lead V or V lead I. I'm not sure whether you still remember how. Do you know how to see I lead V or V lead I or not? Class, do you know how to see or not? Yes or no? No worry. Don't feel that you are wrong in this class. Nah? If I say you are wrong, I will correct you. Rather than when you go out, then you don't know, and then you are wrong, and then somebody will scold you like this. Nah? I will share anything that I know. So, do you know how to see I lead V or V lead I or not? Yes or no?
Forgot already.
Forgot already. Okay, sorry. I should put option C. Forgot already. Or don't know. You have 4 options. One is yes, one is no, one is forgot, one is don't know. So we have what's your name? I just now say forgot one. No worry.
Zahir.
Zahir forgot already. What about others? Yes or no?
No, sir.
What's your name?
Razi.
Razi. Oh no, I forgot to. Yeah. Okay, that's nice. Okay, I need to jot down the name here, or else I don't know how to give marks. Zahir. Siapa lagi ya tadi?
Razi.
Razi forgot it, right?
I don't know, sir.
I don't know. Okay. Who's that? I need to jot down because I need to give marks. Forgot.
Saiful.
No.
Saiful don't know. Okay, siapa lagi don't know? Ada lagi tak?
Saya Ashraf.
Ashraf. Okay. Okay, so for example, you don't know, you forgot already, it's okay, no worry, I will let you know. So we have two ways to see it. One way is from the signal, this is we call signal diagram. This is called signal diagram. Another one is a phasor diagram. Phasor diagram tu nanti kot, bukan sekarang lah. Later on I will show you. So how to see is depend on where is the touching point to the t-axis. So for example, this curve is I, this curve is V. Okay, so we'll see that, okay, according to this line as a benchmark, we'll see I is touching first. This is called the past. Sebab time the past kan. This is called future. So in the past, I touch first. Future, V baru touch. Maksudnya, I is leading V. Same. Okay. This one will say this is benchmark, past, future. So I touch first, baru sampai V touching. So it is I lead V. But how many degrees depend on here? Here. I mean from this point to this point. Ataupun from this point to this point. So it's by 80 degree, by 110 degree. And then, for example, this one, if let's say we extend like this, then you ask, hey, doctor, this time you say touching first, it become leading, right? But now, I touch first. But why is V lead I? One thing is, this is negative, we call negative plane. Okay, we are not looking at negative plane. We are looking at the positive plane. So this is positive versus positive. Positive versus positive. Okay, so from here it's very obvious. V touch first and then baru sampai I. So V lead I by 160 degree from here to here. Okay, so this is how we see the I lead V or V lead I lah. And then how can I put it into a phasor diagram? Let me think. How can I put it in a phasor diagram? It is at 0. And it is positive. Okay, so let me try to put it in a phasor diagram. Maybe I need to, okay. Do you still remember phasor diagram or not? Guys? Forgot already. Still remember or not?
Not.
It's okay. So, okay, phasor diagram is something like this. Maybe I change color first. How to change color? Let's say this is my, okay. And then I change another color. Okay. So basically phasor diagram is a circle. Let me put it in pen. Let me draw the yellow first. Yellow. Okay. So have a see this point. This point is actually reflect as here. And then when you go to the top, okay, when you go to the top, wait. No. This is reflect. No, this is only can reflect the amplitude. Okay. This point is reflect somewhere to here. Maybe I draw a little bit. Somewhere to here. And then when this point is up to here, it will be located at here. Then when going down again, it will go down here. Then going down. Then going down. Then it touch at 0. it becomes here. So, nampak tak? When I say this point, actually this is the vector. When I say this point, it becomes at here. When I say this point, it is at here. When I say this point, it is at here. This is a phasor diagram. We call that it's a phasor diagram. So for example, this point is at here, so we draw this one. Then now we want to find the V1. Okay, V is this color. V is this one, where it's somewhere about negative plane here. Maybe it's somewhere here. So this is a V. Okay. So betul tak? Tak betul. Kat sini baru betul. Sorry, kat sini baru betul. Sebab nanti dia kat sini, dia sudah akan berada kat sini. So sorry Okay. So for this position, dia punya the I is here, then the V is here. So how to see I lead V? The first thing is we need to put an I. We need to put an I here, and then we just stand. And then we know that the phasor is rotating like this. For example, when this point is here, so it's like here. When this point is maximum, the vector is come to here. When this point is here, the vector is here. So we can see it is rotating. Am I right? It is rotating. So this is the default rotation, which means we assume this is a positive value. Okay, positive direction. If let's say rotate like this, which means it's a negative direction, but we are not touching this one. We are assume that they rotate as a positive direction. So how we know that I is leading V or V is leading I? First, we need to stand here and see. Okay, see the rotation. So when I stand here, what we can see first? We will see I first, right? We will see I first, and then we will see V is coming to our way. Am I right or not? Am I right or not?
Yes. Yes.
Okay. So which means now I is a leading V. This is how we see. So we have two types to see. One is a signal diagram. One is a phasor diagram. So this is how we see it But just a refresh only And then okay, now let me change back. Okay, determine the average value of the waveform. I'm not sure whether you still remember the average value or not. Do you still remember how to find the average value or not? Guys, do you still remember how to find the average value or not?
Average value tengah-tengah
Ya betul. Lebih kurang macam tu. Apa nama? Sapu.
Ya.
Okay, that's
Tapi tak
good.
tahu.
Tak apa, it's okay. It's okay, no worry. So for average value of the waveform, we need to see the area under the curve. Area under the curve. Okay, how to see that? Okay, let's say we chop. We don't want to see this part. Okay, we don't want to see this part. We only focus on this part. Let's say now, Saifu, we need to find the average value for time 0 to 1 for this signal. So what is the value? The value is area under the curve, then divide by the total time. We call mean. Mean. Okay, how to do that? This is a 1 second, right? This is a 10 volt. So we use 1 times 10 divided by 1 second. So this is the average value. Boleh faham tak?
Boleh.
Boleh. If let's say we say, we don't want to find the average value for only one cycle. We want to find a periodic cycle. So we found that this is one period. Then this is another period. This is third period. So we want to find the average value. How? We chop into one period first, and then we find the average value. We know that this is average value of 10, and then this is average of -10. Why? Because 1 second times -10 magnitude. So 10 plus minus 10 divided by 1 second plus 1 second because 2 seconds, right? So it becomes 0. So this is 0 value for the average value. Boleh faham, eh?
Boleh.
Thank you very much. So we try to see another waveform. So this is one period, repeated second period. So what we need to do is we need to find the average value. So this is a 14 because 1 second times 14. 1 second times -6. So this is -6. 14 plus -6 divided by 1 second plus 1 second become 12 divided by 2. Betul tak? Sorry, tak betul. 8. 8 divided by 2 become 4. So this is the answer. Okay, average value. But the problem is when it comes to the AC, if let's say we use average value, if it is not true, it is not valid. For example, now we say that this is a 230 volt. Okay, then we connect to the power outlet. Okay, power outlet. Then we use a multimeter to measure. Okay, then we found that, how come the value is 0? So when it is 0, maksudnya dia tak ada voltage. So are we safe to touch it or not? We are safe to touch it or not? We are safe to touch it, right? But when we touch it, then we will die because the indicator is wrong. So average value cannot be applied in AC signal. We need to find another true value. That one is called RMS. Okay, later on. So for this complete cycle, the average is 0. For this one, we still have a 3.18 volt as a average value lah. But the problem is we are not interested in this one because average value is not true. It is not true. So the true value is we call RMS value, root mean square. Root mean square maksudnya root mean square. Macam ni. Maksudnya kita squarekan dulu dia punya data, kita meankan, kita baru rootkan. For example, we have a 0, 3, 5, 4, 0. For example, like this. What we want to do, if let's say we want to find the root mean square value only for this cycle, for example. How we do that is we use 0 square, this one, plus 3 square, plus 5 square, plus 4 square. For example, minus 3, minus 5, minus 2. Let's say we want to find the root mean square until here. Okay, I plus minus 3 square, I plus minus 5 square, I plus minus 2 square. First, I need to square first. Then, what I need to do? I need to meankan dia, average. Maksudnya mean itu macam mana? 1 kali berapa tempo tu. So, for example, this is 2 second. So, I give 2. Sebab dia punya time is 2. Okay? And then, we square rootkan dia. This is called RMS. Root, kita squarekan dia dulu for every data. Kita cari dia punya mean. After that, we find the root. This is the root mean square. And then we will get a value. Instead of 0, we should have a value somewhere around here. Okay? Finish already. So until here, understand or not? Until here, okay or not?
Okay, sir. Okay.
Okay, okay, so this is the basic. I hope that this basic can help you in your FYP as well, especially you're dealing with a signal. So we continue. Okay, today we will start the first class, introduction to the machinery principles. So first of all, we will talk about what is the electrical steel. Electrical steel are distinguished by their excellent electromagnetic. Okay. If let's say you still remember ET208, I talked about electromagnetism. Can anyone help me to remind me what is electromagnetism? Electromagnetism. What is electromagnetism? This is the keyword in this subject. The keyword, the main keyword. It is also the main keyword in ET208, electrical power technology. So tell me, what is electromagnetism? You can simply hum to me, come. Hey, the more you say, the more you get.
Magnetic force.
Okay, we have a magnetic force, right? Magnetic force. Siapa tu? Saiful ah?
Yeah.
Saiful, okay. Thank you very much, Saiful. Anyone else? What is electromagnetism? Cepat. Come. Give me some idea. What is electromagnetism? Saiful saja kah?
Magnet that use electricity.
Magnet that use electricity. Magnet that use electricity. You can give me keyword, no worry. Maybe one word also can. No problem. What do you know about electromagnetism? Maybe you can give me, for example, siapa? Nama tu siapa?
Zahir.
Zahir, okay. Sorry, I still quite fresh. I cannot memorize your sound yet. Zahir, give two keywords. One is a magnet. One is electricity. Anyone else? Anyone else? Come. Come. Ini padahal kenapa tau? Sebab semua orang buat online teaching, online learning kan. Semua sudah lupa habis dah. Betul tak? Apa lagi? Anything. What do you know about electromagnetism?
Interaction antara magnetic field dengan electric field.
Okay, interaction. What's your name,
Arifah.
Arifah, thank you very much, Arifah. Interaction between magnetic and electric kan? Saya lupa tadi. Apa tu Interaction between magnetic field and electric field kan?
Yeah.
Oh, this is paling tepat sekali. Sama, tapi dia sudah habaq that's good. Thank you, Arifah. This is the most close definition to electromagnetism. When we it is very easy only. You see this from this word. When we talk about what apazem, first this zem is called mechanism. Okay, mechanism ni adalah satu perkataan. It is a word that can include a lot of meaning. Termasuk interaction kah, pertukaran kah, conversion kah, continuing kah, anything. It is a mechanism of between of what? Electrical field and magnetic field. Only these two things. So this is the most close definition. Thank you very much, Arifah. So this topic, we only talk about anything that related to the mechanism of between electric field and magnetic field. So where's the electric field here? This is from the electric field. What about the magnetic field? This is a magnetic field. So that's why one word it can define everything. It's a mechanism that involves electrical field and magnetic field. And we don't bother whether you are changing from the electrical field or magnetic field to electrical field. We don't bother it. As long as it is related to this, if all under this mechanism, then we call electromagnetism. Electromagnetism. Right? So, electrical field are distinguished by their excellent electromagnetic properties. Maksudnya, electrical field ni a lot of properties, very strong properties that they can involve in the electrical field and magnetic field. So each electrical field have their own electric and magnetic properties. So when we talk about electric properties, we have a plus, we have a minus. When we talk about magnetic, we have a north, we have the south. And then the same thing is the plus will push the field to the negative side. The north will push the field to the south. That's it. Magnetism, not important. I just brief you lah. So, for example, we have a magnetic induction and the strength of the applied magnetic field H. Okay. Usually, we will take vacuum as a benchmark. Benchmark means standardized for us to compare. If let's say we use copper, argon maksud gold, silicon, argentum, zinc, compare with the vacuum, karakteristik dia kat bawah sikit. If let's say we use aluminium, chromium, tak tahu apa, natrium, titanium, tak tahu apa, compare with the vacuum, it is a little bit higher. If let's say we use a ferrum oxide, nickel ferrum oxide, cobalt, ferrite, nickel, cadmium, ini adalah dia punya karakteristik. H is actually ampere turns per meter. Magnetic induction is we want to use electric. This curve is actually, if let's say I put 1 ampere, how good the magnetic field that we can get. That's why we are in electromagnetism. We want to know that if let's say through the medium, through the satu bahan, kita bagi satu current, how good we can get a field. For example, we give a current here, how good the field we can get it. For example, like this. So let's say 1 ampere kat sini. Okay, I apply 1 ampere because this is ampere turns, right, per meter. Let's say I use a simple one, 1 ampere. We have found that this is about 2 Tesla for diametric properties. This is about maybe 3 Tesla. This is about maybe 1,000 Tesla. So if let's say we want to get strong magnetic field, which one should we go for? We will choose the bahan macam ni. Ferromagnetic. We call ferromagnetic or ferrimagnetic. This one I think you learn during your year 1. That one is called what? Science, is it? What is the subject? The year 1 subject, the 2 credit one.
Engineering science.
Engineering science. Saifu again, right? Is it? Or Zahir? Saifu.
Careful.
Saifu. Okay. Thank you very much. Saifu. So, engineering science, I think you learn about that and very deep. So I will not repeat lah. But as long as I just want to promote that, when we want to start the subject, we need to promote something, right? Now I'm promoting Selcom. Okay. So Digi tak mau pakai, Maxis tak mau pakai, sila pakai Selcom. Okay. So a magnetic field can be produced by putting a current through a coil. So when we put a coil, and then we give a current, and then we will have a field. That's it. Then magnetic induction occurs when the material is subjected to a magnetic field. Is change in magnetic moment from the electrons. Well, if I say I have a bar here, okay, initially field is 0, but if let's say I put a current, then the field become 1 Tesla. Then this is called induction. The type of material respond to the field. We have a ferromagnetic, we have a paramagnetic, we have a diamagnetic. So paramagnetic, as just now we discussed, it is very poor. And then this diamagnetic is opposing. We can see here we cannot see the opposing lah. But the characteristic is opposing magnetic moment. Moment maksudnya tarikan dia. Moment is tarikan. Tarikan. Then large magnetic induction, just now already discussed. So hard magnet will have a large coercivity. Soft magnet will be small coercivity. Here, mana coercivity? Okay, here I will tell you about the coercivity. Okay, so what's the time now? Almost. Magnetic field due to electrical current. Just now, Arifa is very good. Okay, we rest here for 10 minutes first. Come back after 10 minutes. Okay or not?
Okay, sir. Okay.
Yeah. Thank you so much. Let me stop recording first.